First, I'd like to thank you very much, Share Center, to give us that opportunity. And I'd like also to make a small introduction about how this is started. During 3 years ago, more or less, ANACOM identified the need of the replacing the actual CAM ring. CAM ring stands for Continental Açores Madeira Interconnection, and that interconnection nowadays is made through 3 submarine cables that interconnect the continent, Açores and Madeira in a ring configuration. The actual CAM ring will reach the end of life by 2024. That means we'll have to have a new CAM ring operating during 2024. For that purpose, ANACOM identified the situation and asked for the industry and gave the information that we'll have a new CAM ring in operation. 2 years ago, more and less, 2 years ago, our chairman of ANACOM board made a clear challenge to the industry. That was to have in that new CAM ring the possibility to have seismic and environment detection. Immediately we began a search about what was available and for seismic detection using the submarine cables. And we were very surprised because we did discover very interesting things. One, that JTF, Joint Task Force for Smart Cables, was approaching this, and this Joint Task Force is have the support of ITU, that's the Agency for Telecommunications from the United Nations. UNESCO IOC was involved too, and WMO, the Agency for Weather from the United Nations. After we discovered also that in Portugal there were people already tackling this subject. We were very surprised and to know that Instituto Telecomunicações, IT, was involved on this. And from that time on, with the IT and IPMEA, IPMEA is the National Institute for Weather and Sea, we began to try to develop and discover new people that could be involved. Afterwards, the IDL, Instituto Dom Luís, from the University of Lisbon, the geophysics, was involved, and we begin to discuss the possibility to go ahead with some kind of a team to investigate the possibility to have the new CAM ring and all submarine cables, telecom cables, to have those submarine cables the possibility to have seismic and environment detection. We took some time to do it, but some time ago a team was formed, and they call them that team Leia team, Leia a partnership, some kind of a partnership between IT from the Instituto Telecomunicações from IST, that's the Engineering University in Lisbon, one of the Engineering University in Lisbon, IDL, the Instituto Dom Luís from the Faculdade de Ciências da Universidade de Lisboa, from Lisbon University, and IPMEA, that's the National Institute for Weather and Sea. I won't take much more time. I'm going to give the floor to Professor Yasser Omar from IT that will talk for the LEA on behalf of LEA partners. And afterwards, we'll try to reserve some time for questions and answers. And if we won't have time to take care of all the questions, for sure we'll have opportunity to have the disposal afterwards the presentation of Professor Yasser Omar, and also some kind of a report of all questions and answers. It was a small introduction, I believe, and I will give the floor to Yasser Omar now. Please.
Well, thank you very much. Let me share my screen to show you my presentation. But first and foremost, let me thank you, Jose, for your very kind and clear introduction, and also to Jose Luis Motinho and to the Air Center. It's a great pleasure to be back to these Atlantic interactions, even if this time virtually. But I think this is a very interesting initiative, this Networking Friday, so congratulations for finding this solution to keep us in touch during these times. So I'm going to tell you about this new project called LEA, which stands for Listening to the Earth Under the Atlantic. And this is a project in collaboration between Instituto Tecnico, my research center, and colleagues whom I'll introduce from IPMA and IDL, as Jose also mentioned. Can you see my mouse? Can I use it as a pointer?
Yeah.
Well, can I use this another pointer? Let's see. Yes, I think I can use this other pointer. Okay. So let me start by saying that I'd like to say our planet is alive. This map here shows seismic activity recorded from 2000 to 2008 across the globe, earthquakes with a magnitude of 5 and above. And as you can see, most of this is happening in the ocean floor. And in fact, the ocean floor is something we don't know that well. We know the surface of the moon better than we know the ocean floor. So how can we get information about all this seismic activity that is happening at large depth? Well, one solution are these ocean bottom seismometers, and the ones I show you here, they were built by Carlos Corella and Luis Matias, who are part of Instituto Dom Luís, a research institute from the University of Lisbon, and who are also part of this project LEA. And let me zoom in on one of these just to show you how it looks. So essentially, there's a weight or an anchor to make sure the OBS goes to the bottom of the ocean, but then there's also a hook, because then once it's done its job, you need to fish out and retrieve the data. And these are some of the challenges of this technology to obtain seismic information from the bottom of the ocean. These devices are relatively fragile. Of course, they're quite sturdy, but still in the long run, they have some vulnerabilities. But one of the main constraints is that this is not real-time information. So you submerge this sensor and then you go and fish it out 6 or sometimes even 12 months later. So essentially, you do not get real live data. You get retrospective data that is useful for scientific research, because you can then trace back seismic events that were recorded on land or from land seismometers and compare, but it's not at all real-time data. This is also expensive technology, especially to deploy and retrieve, because you need to send a boat on a mission for several days, and this has very significant costs, and has limited coverage, as you can imagine, because of all these constraints. And it's estimated that if you wanted to have a relatively significant global rollout, this would be in the order of the billions of euros. I mean, I should say there's of course some ideas and solutions and attempts to make this information retrievable in real time. And so here's a proposal from a few years ago conveying a very simple idea of this OBS, the ocean bottom seismometer, emitting this information that is then captured by some antenna here that then in turn transmits via satellite. But this technology is in fact not so robust. These buoys are not that resistant, and so it's not a very satisfactory solution in the long run. Let me give you a different example, which was this unfortunate event, earthquake in Indonesia, followed by a tsunami in late 2018. And in fact, there's an early warning system for tsunamis, also based in buoys, which essentially was no longer operating. And this was one of the causes of the tragedy in terms of not being able to predict the tsunami so accurately as it could have been. Why? Because these buoys, first, they're expensive. Second, they're not that resistant. They're subject to different actions, including people who destroy them or who take some of the GPS, etc., to use fishermen, etc., who take some of the equipment, or they need replacement in batteries, etc. So overall, it's not functioning very well. So overall, these systems, they have all these challenges. However, as Jose mentioned, a quite unique opportunity arose here in Portugal, and this is the idea of this new telecom infrastructure called the CAM ring, which will need to be deployed in Portugal by 2024, simply because the current infrastructure is going to expire soon. And this is something that the lifetimes of these submarine cables, these will be optical fiber telecom cables, is more or less 25 to 30 years. So this is an opportunity that you get, 3 times a century to replace this technology and this infrastructure. So as it was explained, CAM stands for a connection between continental Portugal, the Azores archipelago, and the Madeira archipelago. These are the Portuguese territories in the Atlantic. And as explained here, by 2024, Portugal needs to deploy a brand new set of optical fiber telecom cables to connect these regions. And we're talking more or less of a distance of 1,500 kilometers between the Azores and continental Portugal. And then the other 2 branches are about 1,000 kilometers. So it's a triangle or a ring, as Jose introduced. And so the opportunity is that not only we need this new infrastructure, and again, this is an opportunity that comes every 30 years or so. Furthermore, the Portuguese state and ANACOM, our telecommunications regulator, to which Jose Barros belongs, they can request additional services for this new infrastructure, namely public services for civil protection, as well as scientific monitoring for research. This is also a unique opportunity that this can be requested top-down. Furthermore, this constitutes an opportunity to establish a permanent and real-time submarine observatory in the Atlantic. And how can we do this? Well, first we can attach geophysical sensors and other sensors to the submarine telecommunication cables, or to be more precise, typically what one would aim would be to attach that to the repeaters. So the repeaters, as you know, any information signal that is transmitted via cables or via waves attenuates and needs to be re-amplified, retransmitted, or as we also call it, repeated. So these cables, typically about every 80 kilometers, they have one of these devices called a repeater, which is there to make sure you can carry the information to long distances. And here's an image just to give you a scale of these objects. And also I wanted to show you here a repeater and also a branching unit when you have to branch out these cables. And this is a photo from a very nice exhibition that is at the Museum of Communications in Lisbon, which is part of the Portuguese Foundation for Communications. They had a very nice exhibition called the Submarine Cable in the Sea of Connectivity, about the history of submarine cables, where you could visit these devices. I think the exhibition is now being reorganized and has or will open soon. So I recommend this visit for all those interested in this very fascinating topic. And by the way, by going there, you can also learn that Portugal actually played a historical role in submarine communications in the Atlantic, namely in the Azores. You have a photo here of a telegraph cable being deployed in 1904, belonging to this German Atlantic Telegraph Company Society. But in fact, since 1855, the first plans started being developed to use the Portuguese islands to connect Europe and North America by telecommunication cables. And in fact, so this is in the island of Faial, and they also have a very nice museum where you can see all these historical objects that allowed these telegraph communications and then electric communications and now optical communications between these different continents. But coming back, so I'm repeating my previous slide, coming back to this plan or this opportunity to establish this permanent and real-time submarine observatory in the Atlantic is to attach sensors to this telecom infrastructure, which is something that has never been done before. In fact, there are a few, very few dedicated sensor networks under the sea in Japan and in the west coast of Canada, for example. These are extremely expensive, and these are completely different from the more than 1 million kilometers of telecom cables that exist now under the sea. And this distance is actually growing. So these big companies like Google, Amazon, etc., they need transmit more data, so they are, as we speak, deploying more and more cables around the globe. More than 99% of communications in our planet go through cables. So what we're proposing here is I mean, if we deploy this, this will be unique to have a hybrid network that is both for communications and for scientific sensing, and this would be attached typically to these repeaters. We have other ideas that would allow us also to try and do this sensing on land in the landing stations, but this is ongoing research that I will not cover so much in this talk. So summarizing this point is we see this new telecom infrastructure as a unique opportunity, and this has been dubbed the SMART CAM, where SMART stands for Science Monitoring and Reliable Telecommunications. And so it's this idea of having this telecom infrastructure that in a hybrid fashion also includes the scientific sensors in the same network, not as a separate network. And yet another advantage is that this would all be in the Portuguese economic exclusive zone, which is also something making these type of projects easier. So unique advantages of this plan and project is, well, as I said, the real time. This gives you live data, allowing to then exploit this live data to have more accurate early warning of tsunamis, Maybe earthquakes, although this is, would be extremely limited and it's still ongoing research, but in any case, it would give you better, whatever predictions you could do, and probably you can't do much in terms of earthquakes, it could be better with this data, but certainly this would have a significant advantage for the early warning of tsunamis, and that's already, motivation enough for such an investment. And if you have seismological sensors, why not have also other types of sensors that can give you an environmental monitoring of what is happening at the bottom of the ocean, which is not well known at all, but has many implications for our climate. And this is extremely important, especially in this context of climate change. So this real-time data is really a very special advantage. Then the cost, as I said, it's technically feasible to have a network of such sensors that is connected and outputting the data in real time. But so far, what exists in our planet are many, many telecom cables that only do telecommunications, and very, very few dedicated networks for this scientific sensing, for this seismological and environmental sensing. And the main reason there's so few is that they are extremely expensive, right? And so here, the idea and the opportunity, is that since if we are going to invest in a new telecom infrastructure, maybe just by a 10% top up, you can actually try to include this sensing network as opposed to the unbearable cost of investing in a dedicated sensing network. And this is essentially the reason why almost no other country besides the few I mentioned have such dedicated networks, is because it's extremely expensive. Then the coverage, right? So as you've seen, this is a triangle with 1,000, 1,000, and then 1,500 kilometers, more or less covering, almost a third of the Atlantic between Portugal and the US. And so in a very relevant area in terms of seismic activity. And so this would be also a very unique advantage of this platform. Finally, from a Portuguese point of view, such a new type of hybrid infrastructure providing this scientific observatory would give Portugal almost 600 years later, again, initiative and pioneering aspect in the Atlantic as we started several centuries ago. And of course, this initiative being based in Portugal, because this is a sovereign infrastructure, is open to the world, because this is science and it's about sharing data not only for our knowledge of nature, but in fact also for civil protection to the Portuguese coast, but all the coasts around, in particular south of Spain, Morocco, etc. And also there's the unique advantage that this infrastructure belongs to a single state, in this case Portugal, and lies on the Portuguese exclusive economic zone, which makes, again, lifts a number of very non-trivial obstacles to deploy such type of sensing networks. So the question now is, how can we explore these advantages? Well, this is how this project was born. So Project LIA stands for Listening to the Earth Under the Atlantic. This is an initiative of 3 research centers, IT, ITMA, and IDL, inspired by this vision of ANACOM, our telecommunications regulator, on smart cables and the infrastructure of this cam ring that needs to be deployed by 2024. So let me just introduce our research organization. So myself and my group, we are at the Instituto de Telecomunicações. The Telecommunications Institute would be a translation, and we are a national research lab dedicated to all things telecommunication. I'm also affiliated with Instituto Superior Tecnico at the University of Lisbon. And our 2 partners are ITMA, the National Meteorological Institute, also with responsibilities in terms of geophysics and in fact early warning for tsunamis. And our third partner is IDL, which stands for Instituto Dom Luís, a research institute which is part of the University of Lisbon with a leading role in geophysical research. And those photos of those ocean bottom seismometers that I showed at the beginning of this presentation are in fact developed there by our colleagues Carlos Corella and Luis Matias. And so what are the aims of our research project? Well, first and foremost is to investigate the use of submarine cables, and in particular telecom cables, although of course there are also some incipient networks also in Europe for dedicated networks to scientific sensing. But in particular, what would be innovative here is to use telecom cables for this real-time scientific monitoring of seismological and oceanographic data. As well as, of course, their applications to civil protection. And so one big goal here is how to then use such real-time local data from the bottom of the ocean for much more accurate early warning of tsunamis. But again, also temperature and other information from the bottom of the ocean is extremely relevant and not known well at all for understanding oceanography and its implications and connections to climate. And it's a significant role that the ocean plays there. And so this has also that novelty and impact. And even this could also be studied, used for investigating migrations of marine mammals, etc. And new ideas for the future. Who knows, after you deploy these sensors, what you find and what ideas you have and what new science and applications and innovation you could develop. Thirdly, and very important also for our initiative, is to advise our national authorities on strategic and technical specifications for such a network. It's a very important technical work that we've been developing. And in particular, I want to give a shout out to Vasco Sá from Instituto Tecnico, who's been working together with the colleagues I mentioned, Carlos Corella and Luis Matias, and also with Fernando Carrillo from IP. And finally, we also have a vision that this is a new opportunity for scientific outreach to bring science to the general public, and in particular to school children, and to attract them to science, because you can see data live maybe on your screen of your mobile phone coming from the bottom of the ocean. And I think that's a great opportunity also to build a whole agenda of scientific outreach and promoting the importance of geophysics, early warning of tsunamis, but also environmental agendas, and even related to marine biology. And finally, I want to stress that this initiative is open to collaboration. So anyone interested in getting involved, please do get in touch. We have an open approach to what we think is a great opportunity, and great science is done with great collaboration. So we welcome those. Also, I want to stress that not only this is inspired by the vision from our telecom regulator ANACOM on having the camering with smart cables, but there was a very important role and context that has been an ongoing effort for more than a decade of this so-called Smart Cables Joint Task Force, which is a partnership between three United Nations agencies, and I think Jose also referred to those in his introduction. So we have the ITU, the International Telecommunication Union, the IOC, the Intergovernmental Oceanographic Commission from the UNESCO, and also the WMO, the World Meteorological Organization. So in the context of these three agencies from the United Nations, this Smart Cables Joint Task Force has been constituted, and I want to acknowledge the leadership of Professor Bruce Howe from the University of Hawaii, and who, this Joint Task Force for more than a decade has been promoting this idea of hybrid cables, meaning telecommunication cables with a sensing capability. And this context and support and forum for very interesting and stimulating discussions has been extremely important to us. So I want to introduce the team coordinating Project LEA in these three institutions that I've mentioned. And I've introduced you Carlos Corella and Luis Matias, who are also, besides theoretical studies that I will also show in a few minutes, have been developing that equipment, the oceanic, the OBSs, ocean bottom seismometers. Fernando Carrillo and his team at our Meteorological Institute, who have not only also great expertise in geophysics and earthquakes and tsunamis and the sensor network on land, but also leading the responsibility that this National Institute has in the early warning of tsunamis in the North Atlantic. And also the team in my group, so Manfred, an expert in optical communications, Manfred Nihus, Rui Perdigão, an expert in data analytics, which has very original ideas for novel approaches to data analytics. Vasco Sá, who was responsible and chief engineer for the deployment of submarine cables in Portugal. And so we constitute the team coordinating Project LEA, but of course there's a larger team behind. And so let me conclude by trying to show some simulations on the impact that this new telecom infrastructure, CAM, connecting continental Portugal, the Azores archipelago and the Madeira archipelago in the Atlantic, could have if it has, as we expect, this smart capability. So let me first just show that this area that we're talking, so here's mainland Portugal and of course Spain and Morocco. Here is the Madeira archipelago, here is the Azores archipelago. And as you can see, over the last century, we could record from seismometers on land seismic activity. And here just we're considering these larger earthquakes, and it's a very active area, in particular here, the Gulf of Cadix, which is extremely active and can have significant earthquakes here, can have a significant impact on land. And unfortunately, very famous one is this earthquake that took place in the 1st of November of 1755, which completely destroyed the city of Lisbon, because after the earthquake, there was a very devastating tsunami, which in fact affected not only the south of Portugal, but as well as Spain and Morocco. And it was in fact observed even in UK and in the Caribbean across the Atlantic. This was one of the most destructive earthquakes recorded in history and sent shockwaves in Europe. Even Voltaire, the French philosopher, wrote about it. And precisely the origin of this earthquake is in this area here in the Gulf of Cadix. And so here I want to show you the sensing network that ITMA has, our Meteorological Institute, to monitor seismic activity. And naturally, this is all on land here in mainland Portugal and in our archipelagos here, right? And so the big novelty, of course, is that now if we put seismic sensors in this CAM ring, in this telecom infrastructure, then we are closer to where things are happening. And so here's the data or the technical details or principles that were used for a simulation. So Fernando Carrillo at ITMA and Luis Matias at IDL, they made a simulation assuming we have some sensors in the bottom of the ocean connected to the CAM ring. And so these are these red triangles here. And with some, I will maybe in interest of time skip the technical details and leave more time for questions now or any time in the future. But so here is a simulation assuming we deploy these red triangles. These would be sensors in the telecom infrastructure at the bottom of the ocean. And with that, what we can see is that we have some, we gain time. We can detect seismic activity faster because the sensor is just closer to where things are happening. So here is the existing networks. So it's the green triangles that you can see here. And here is a simulation based on future deployment of these red triangles. And that will be the CAM smart ring. And maybe the time is not so clear here, but you see a difference in colors. I will give a maybe more visible example in a few seconds. But essentially, this is to demonstrate the advantage of this infrastructure. And it's it's not only about time, and in fact, maybe something more important than time is the accuracy, the quality of your information and of the predictions you can make based on this information. And technically, as I've learned from my geophysics colleagues, so I should have said from the beginning, I'm not a geophysicist. I find this fascinating and have been learning a lot in the last couple of years, interacting with these nice colleagues and collaborators. I'm actually a physics of information person, more related to quantum information and quantum technologies, in particular optical networks and communications in that regime. But so as I've learned from my geophysicist friends and colleagues, is that in particular quantity called the azimuthal gap is crucial for the quality of the predictions that we can make. And I think anyone will understand that if you have some scientific data and models and a mechanism to launch an early warning for a tsunami that will evacuate the shore of different cities, etc., you don't want to generate a false alarm, right? And currently, the accuracy of the predictions and early warning that could be launched based on these green triangles, the terrestrial sensors, is not satisfactory. And so there's this huge dilemma, which is you have some data measured on land from an earthquake that happened in the bottom of the ocean or beneath it, in fact, you predict that there could be a tsunami, but the accuracy of your prediction is not good enough, and so there's this dilemma of when to launch the alert or not. So this is not only about launching the alert sooner with these ocean bottom sensors in the telecom infrastructure, is launching an alert based on a much more accurate prediction with much more certainty, and this can make in fact the entire difference about protecting lives and infrastructure with such warnings. Okay, so I'm not going into the details, but essentially here you see that the change in colors is revealing a much better quality for this quantity, the azimuthal gap, which represents then better accuracy and certainty in your predictions. So as I mentioned, in fact, IPMA, our meteorological institute in Portugal, has facilities for earthquake monitoring, and in fact, it has the responsibility to be a tsunami early warning center in this region of the North Atlantic. And so they do, of course, need accurate and reliable data. And so maybe a more visible advantage than the previous plots and heat maps that I showed is this simulation, again done by Fernando Carrilho and Luís Matias, going back in time with some data from an earthquake and information from 1969, February 1969. And if we had this infrastructure, the smart cam ring, then we could gain in time 12 minutes in the prediction. And another simulation based on an event in 1941. Here's the epicenter, let's say, and here's the future smart ring infrastructure in these green red triangles. Then here the gain in time would have been 36 minutes. So let me conclude because I think it's time, and summarize these ideas. So the main point is that we have here a unique opportunity in time. Why? Because we need to replace this expiring telecom infrastructure. As I said, this is an opportunity that comes every 30 years. So either we do it now or we do it in 35 years. An opportunity in space, because this is all within the Portuguese economic exclusive zone. And so there's one entity, one state, and this lifts a series of extremely non-trivial legal challenges that would otherwise be there, and also a unique chance in procurement because the customer here is the state, the Portuguese state, and the Portuguese state can, tell the whoever is selling them the cables, they say, we want this feature in the cables. Okay, so this is a unique opportunity in all these aspects, which I think it should not be missed. Then this can have really a transformative impact in terms of our understanding of seismology and its applications to the early warning of tsunamis and civil protection, for sure for Portugal and all the neighboring countries, in particular Spain and Morocco, but of course also for the world, because this would be scientific data available to the entire scientific community. But also hopefully this pioneering example would help other nations and other regions of the world to take a similar initiative and deploy in the future a much wider and eventually global network with these features. And finally, for Portugal, this is of course a unique competitive advantage and pioneer leadership and pioneering role we can have for our science and our civil protection. And this is then a public service in terms of civil protection, data for civil protection that can be provided to national and international communities. And repeating what I said in the previous point, that we would hope to be replicated around the European Union. And I acknowledge some dedicated sensor networks that the Joint Research Center from the European Commission has been deploying and around the world. And so this is it. This is the idea and the plan of Project LEA, listening to the Earth under the Atlantic, or as I also like to say, seeing the Atlantic as it was never seen before. So let me just acknowledge my research group and all the funding agencies and programs that are supporting our research. Let me once again, of course, acknowledge the great coordination team of LEA, Carlos Corel and Luís Matias at Instituto Luís and their team, Afonso Loureiro, Susana Custódio and others, Fernando Carrilho at IPMA and his team, Rashid Almira, Paulo Alves and others, and also our team here at Instituto de Telecomunicações, Manfred Nihus, Rui Perdigão, Vasco Sá, and others. And I conclude just by repeating my summary slide and thanking the collaborators and partner institutions, IPMA and Instituto Luís, and my own institute, Instituto Tecnico, for setting up this fascinating and exciting project that we called LEA, Listening to the Earth Under the Atlantic. Thank you very much.
Thank you very much, Yasser. I believe we have still time for, yes, we have, for some questions. I know I have some questions in the chat, but I believe also if someone raises his hand, we can take the questions too. Perhaps I could begin with the first question, and I will read it. This comes from Susana Barbosa, and the question is, what are the plans in terms of data infrastructure for the LEA data? Ideas for data preservation and sharing? Question mark. Yes, sir. Something?
So ultimately, this is a decision of the Portuguese government, who will set up this infrastructure, right? But as scientific data, our view is that this should be made available to the scientific community. We've been studying the volumes of data, which in fact are not that significant. So in terms of transfer and recording is not very demanding. So the infrastructure won't require a huge investment for that. And then from the scientific perspective, I think our vision is that this should be shared with the scientific community and the world. I think this is the unique data that has many applications and implications, scientific, civil protection, and so on. Not only seismology, which of course is a huge focus, but also all the climatological and oceanographic implications. So I'm sure there will be more data than we can process, and our vision would be that this should be shared. But I think ultimately it may not be our decision.
Just to comment, if I may,
Please, yeah, actually, you could comment as the regulator for telecommunications. That's, maybe you should answer this.
Regulator. I just want to point out that we'll have that infrastructure working for 25 years. We are talking about to collecting data during 25 years in real time. That's amazing, and that's a huge quantity of data, and should be worked, and we'll have to use it for sure. Just to give just another information, the government set up a working group to deliver recommendations to the government, and now it is up to the government to decide about when we'll have the new Camering, and also to decide about the service that the new Camering can provide behind the telecommunications. Going then for the second questions I have here is from Nigeria. Welcome, Nigeria, Mr. Ibekwe. And Mr. Ibekwe wrote, LAY is a great and timely project, especially for with the issues climate change and biodiversity. That data has always been an issue in Nigeria, not in Nigeria, in every world, I believe. I want to know how we can be part of it so we can provide data for study. This will provide the coverage in analysis for holistic result. Mr. Omar, can you take that?
So thank you very much, Moneka. And hi to Nigeria indeed. So as I said, we're very open to collaborations, and I think in fact the Air Center can also be an additional mediator here as an organization trying to promote, as they call it, and I like it a lot, this terminology, the Atlantic interactions, right? So if you also can complement the data, that would be extremely helpful. I just want to emphasize that we're talking about an infrastructure that will be deployed and ready by 2024, more or less. I don't know if there will be any delays due to the current pandemic. There can't be too many delays because the current cables are expiring by then, so the infrastructure needs to be ready. But so the live data will only come in 4 to 5 years. But in the meantime, as I've shown, we can actually do simulations, and if you have other data that can be relevant, definitely let's talk. Thank you very much.
Thank you. Then next question is from Wendy Watson-Wright. I'm reading it. Thank you for the very interesting presentation. Congrats. Given the connections with IOC, which leads the global tsunami warning systems, how will this initiative feed into that system, especially in the Northeast Atlantic and Mediterranean Sea, NEAMS, part of that system?
So I think the best person to reply to that is Fernando Carrillo. In case it's possible to give to unmute Fernando as a participant, I believe he's there. But while we figure that out, what I would say is that IPMA, our Meteorological Institute, has this responsibility of early warning already now in the context of such networks, right? So I would imagine that this was just continue as is, meaning it's just now they have better and more accurate data to feed into the existing networks that you mentioned, Wendy. Thanks for your question. But I don't know, is it possible to allow Fernando to answer?
Yes, I mean, open up the mic for
Fernando Carrillo.
Oh, and also,
I opened the mic. Thank you.
Thanks,
may
Fernando.
I just ask to rephrase the question, because I was with the problems with the Zoom.
Okay,
Can you just rephrase the question?
I can read it if you want. So
yes,
this
please.
is a question from Wendy Watson-Wright, and she asks, given the connections with the IOC, which leads the global tsunami warning systems, how will this initiative feed into that system, especially the Northeast Atlantic and Mediterranean Sea part of that system. So how would Leia feed into NIAMS?
Okay, in operational terms, the existence of smart cable infrastructure producing real-time data will immediately fit into the existing network of tsunami service providers in the NIAM region. And this on the purely operational view. But LIA also has research objectives, and of course the experts that are running on, that are let's say working for the different institutes that makes part of LIA, can also naturally integrate the ISC experts group.
And
I don't know if
thank you very much, Fernando. There's a follow-up question by Wendy, and she asks, will LIA be a part of the All Atlantic Ocean Research Initiative, ANCHOR? I don't know, Fernando, if you're familiar with this.
No, I'm not aware of that.
I am also not aware, I must say. So this sounds very interesting, and we are not aware. So it sounds like it would make a lot of sense. So if you can please send us more information, or I guess we can also Google it. This seems to be extremely relevant for this initiative.
Yeah,
sorry, Jose, I sort of stepped in, but just to get the follow-up question.
If I could step in, ANCHOR is the initiative that's coordinated by FCT Portugal. That is a coordination and support in action funded by H2020, and basically is for the implementation of the Belém Statement. It's like a sister initiative as AORA. AORA is for the implementation of the Galway Statement, and ANCHOR is from the Belém Statements. It's a very good, I mean, let's say, question. Thank you, Wendy. I will put you in contact with Sofia Cordeiro and all the other people from ANCHOR, okay?
Okay, so it's funny that it takes this international initiative to find out that this European network is actually coordinated next door. So always good to learn these things. I think I know Sofia Cordeiro, but yes, please do put us in touch. Thank you.
You can imagine that would be somebody from Canada, Wendy.
Yeah, thank you so much. It's truly Atlantic interactions. Congratulations, their center.
Yeah.
Jose, if I may help you, I mean, there is Bernardo. I opened the mic for Bernardo. He wants to ask, he raised his hand. Bernardo, can you ask some questions?
Yes.
Bernardo, are you listening to me?
I'm here, but I'm not sure if you are.
Yes, we can hear you, Bernardo.
Can you hear you?
Hello, Bernardo. Well, some problem because Bernardo raised his hand. There must be some problems on the sound. Maybe we could move to the next question from Mohamed Bilal. From Mohamed Bilal. He's from NOC.
The question is the following. So we would put additional OBS on the repeaters with camering. Yasser, can you reply, please?
So first of all, hello, Mohammed. Thanks for your question. So essentially, yes, there could also be accelerometers and other sensors, but the short answer is yes. I guess we're running out of time. Otherwise, I would suggest to maybe open the mic for Carlos Corella or Luis Matias, but we can also follow up offline. But the short answer is yes. I mean, sorry, maybe I was wrong. I meant you put a seismometer, if this is what you mean by traditional BS. Yes, so you put a seismometer, but that's what I meant. Sorry if I wasn't clear.
Yeah. So I opened the mic for Mohamed Bilal. He wanted to talk. So please, you wanna ask something, Bilal?
Can you hear me?
Yes.
Yes.
Hello.
Yes.
Hi everyone. Yasser, wonderful talk. I just wanted to make one quick comment that at
Please.
NOC we would really like to collaborate on this, and I think we sent emails. But very briefly, Omar, I think what you're doing is essentially an extension to what Bruce had been doing. So I'm familiar with that, which is going along on repeaters. But what we would like to really bring on board, this platform, which would really complement this, is our ability to also look between repeaters, which is actually doing truly distributed measurements, i.e. spatially resolved. To give a quick example, if the cable is 150 kilometers long with a single-ended axis, we can resolve every few meters and map the entire cable. So, and I briefly touching upon slightly next level stuff, and you said that you're doing some interferometry. So all of those techniques, we would be able to really complement them well. And together, this can be a really powerful platform where you've got discrete sensors scattered on these repeaters, whilst with our distributed capability, we'll be able to look between them as well. So suddenly, for instance, a thermometer cable turns into a cable which has sensors every 10 meters. So you can see it suddenly converts it into several thousands of sensors all along.
Indeed.
So I just wanted to highlight that point, that we're really excited with this initiative and really like to know from you how we can contribute.
Yeah, I mean, this would be really. Sorry, go ahead.
Sorry, I was simply saying I mean, in no way we are competing, we are in a way complementing. I see this entire ocean capability that we're filling in the gaps, which through the cable monitoring capability. And so having a distributed capability on there will just simply transform enormously. There have been, as you might know, some Lindsay and et al. On making seismic measurements on telecom legacy cable infrastructure. And but the sort of thing I really want to bring on board is this.
No,
sorry, carry on.
No, thank you. Thank you so much. And I can tell you that we've been looking at your paper that you kindly send us, and we'll be in touch. In particular, my colleague Manfred Nihus and also Vasco will soon be in touch. So we've been preparing this. And you're totally right. And this would be extremely interesting. We're also thinking about that. That's when I said the two approaches, where there's the second approach, which is essentially interferometry, but this is ongoing research. So, you cannot guarantee that it will work. It looks quite promising, but it's ongoing research. So here we wanted to focus on, proven technology that really justifies this investment and this innovative hybrid deployment of such an infrastructure. But these other approach based on interferometry is even more exciting to some extent because it's new, but it remains to be proven. So it's part of our research agenda. Thank you very much, Mohammed.
Can we go to the next one from Rui Ponte? The question is there a clear set of parameters and sensors that will be part of that system?
So the answer is yes from our side. So we've been studying this in particular. I want to give a shout out to Vasco Sá and Luís Matias and Fernando Carrilho and Carlos Corella and Manfred Nihus, who's been discussing this and in fact have been interacting with the companies that manufacture these cables and these sensors. So this is a highly technical, a bit strategic, but highly technical a task. We'll go ahead, please. But so the answer is we're working on that, and of course the goal is to have not only the set of sensors, but the clear set of specifications that they should have. So this is something that will be an output of our project. Yes.
Next question, perhaps, or José Luis, do you want to try the microphone to Bernardo Aliaga, or do you want me to go to the next question?
Yeah.
Hello.
Bernardo, can you?
Hello.
Hello. Hello. Yeah.
No.
Yes. Do you hear me?
Yes.
Yes.
Perfect. Thank you.
Actually, this is Dennis Changsang from IOC UNESCO. I'm the technical secretary for NIAM TWS. I think I'm using his link, so that's why it appears as Bernardo Aliaga.
Okay.
But it's Dennis. So I was a bit confused, actually. So
Yes.
thank you very much for nice presentation. So it's very encouraging to see this moving forward in terms of improving tsunami early warning system in NIAM region. And also thanks to Wendy for asking that question. So it's very encouraging because other Mediterranean countries, European countries may also take this as an example. And then this will hopefully improve tsunami early warning system in the whole of NIAM region. I have one little question regarding the time factor. You mentioned that there's 12 minutes of improvement. And in NIAM's region, we have a target of 10 minutes, for example, to issue alerts. So in terms of relative time, how does this work out actually in terms of, is it going to cut the time by a few minutes, or is it going to improve the accuracy and also the timing both at the same time? So that was just a question to clarify. Thank you.
So we hope to get an improvement on both. So the early warning could be earlier, but also, or even more important, it could be more accurate. And so it's not only about getting information sooner, but also getting more accurate information that would allow your early warning to have more certainty. As I said, and as I guess you know better than me, you don't want to send a false alarm, right, and evacuate cities and shorelines if you're not certain, and create panic. So the accuracy is extremely important, and this could give a significant improvement in the accuracy and also in terms of a bit earlier.
Thank you.
Thanks for the question.
Next question from Nun Diaz, which is the time predicted for the deployment of the cable and time period for development of sensors to implement in the cable. Just
I think, Jose, you could answer that question actually better than me.
We have here a constraint. That means we'll have to have a new cable in operation, the new cable ring in operation by 2024. That means if the construction and the installation of the cable will take at least 2 years, that means we'll have been ordered the new cable, not perhaps by the beginning of 2021. The problem is we'll have to order that cable with the specifications that we call smart specifications, not only telecom specifications, but they are very known. There is no surprise on that. But for the smart, if you want to use smart repeaters, for instance, we'll have to explain that very clear to the suppliers what we are wishing to have on those repeaters. And we are very aware that we won't have very much time for that. But Leia is investigating and is in, I should say, cruise speed investigation, try to identify with the suppliers, and they begin to doing that with the suppliers some time ago, not recently, I should say, and they are in dialogue with and they wish to be in dialogue with the main suppliers, And also they are in dialogue also with the sensors suppliers, because we are talking about to integrate everything in the same cable. And but having always in mind that the let's call it the scientific part could not jeopardize in any time, in any circumstances, the commercial telecom traffic. That's I should say, for the operators, a submarine cable, telecom submarine cable, is a kind of a holy cow, cannot touch it. And but we do believe that all the scientific part and the telecom part, they can play it together with making no harm to each other. But that is the main requirement. As I told you, Leia is in dialogue with suppliers. We want, of course, if you are talking about wet detection, we have time, much more time, because we can use that in any submarine cable in operation. And but if you want to use a smart cable, that means with the wet sensors in the seafloor, we'll have to work hard, and we'll have to be very fast in order to identify some kind of a solution that the new operator that will take care of that cable can put in the ready for proposal, RFP, I believe that's what they call it. Yasser, I don't know if you want to complement anything with this.
No, I think that's this is perfect answer. Yes, thank you.
There is another question from Carlos Sousa Oliveira. Why you drop the importance of early warning for shaking?
Okay, hi Carlos. So I guess shaking, maybe, Carlos, you mean earthquakes? And if that's the case, it's just from the scientific, from the technical point of view, it's not possible so far to have early warning. I mean, this is still science and technology to develop potentially, but currently we don't really have that, although of course this is a possibility. So one could speculate about early warning for an earthquake of or the order of half a minute or so. And as Luis Matias often point out, and Fernando Carrillo, this could actually be useful information. Maybe with 1 minute notice or even a bit less, you could stop a train or stop a bridge that is from being open or closed, or even maybe stop a surgery. But this is the best we can hope for at this stage, given our scientific and technological knowledge. So it's not that we don't worry about it. Of course, it would be great if we could predict earthquakes with more advance, but the difference is maybe I should explain. So the difference is that the tsunamis travel much slower than the what you call the shaking, right? So the earthquake will happen, and these vibrations will travel quite fast across the crust, and so there's not much you can gain in terms of time. Whereas if the earthquake center was far in the ocean, even if the vibrations get to the land and to our places where we are and our infrastructure, they get quite fast. The water wave or the wave in the water rather will propagate much slower, and that's essentially the difference. So these earthquakes, the perturbations, the signals, they travel faster than we could act. So it is not that we're dropping, is that there's not much we can do.
I do believe the problem is the epicenter is not sufficient far away from the continent or for Madeira or for Açores in order to benefit from the difference of speed of almost speed light in an optical cable and the speed of an earthquake. Perhaps it's below 10,000 kilometers per second. Nevertheless, I know that is always is not dropped and is always on the people mind, and perhaps who knows, we can have some surprises with this smart cable working and to get new benefits that we cannot see now. I don't know if there is any.
I think the last question is for you, Jose.
The last question now. We had another question here from, we won't have time to reply, from Rui Figueira and Pablo Baunza. And maybe you should reply by email asking, asking if it's feasible to add sound and image sensors to record marine biodiversity.
Yeah, I do believe Laia is investigating the possibility of having to measure the temperature, salinity, and I believe can also paying attention to measuring the currents, and also that will benefit everything related with the climate change and global warming and so on. But Yasser, that's I believe you should be the right person to respond to that.
Yes, so I'll be very happy to respond offline by email or via Jose Luis and their center, since we have to close.
Yeah.
Or
so
just please do get in touch.
A final word to Mohamed. He asked about the dark fiber. To Jose, Bilal asked you if it's possible to have a dark fiber in the ring.
Jose, can you hear me?
Yes.
Hi, just very sorry, just one additional question. There are these amazingly fancy things you're doing. I just wondered, is it possible to have one dark fiber in there, which could open up a whole host of things? So very simply, you're putting new sensors, i.e. traditional sensors or known sensors at repeaters, whereas if dark fiber, which since all the cost of laying is happening anyway, then through the dark fiber, you could actually listen to things remotely. And it would be exactly the sort of complement that I was seeking between us and Omar. Okay. So I was just a simple question, can we have a dark fiber in there?
But yes, answering to you, yes, the new cam ring will have enough fiber pairs to deal with the telecom traffic. Also, we can have, because that's additional cost, one fiber pair is an additional cost for the telecom configuration. And who knows, we can reserve a fiber pair for that if the solution, if the need of having a smart cable will have to have a dark fiber pair just for scientific purposes. Perhaps that could be a solution, but Laia is studying that. Also, I just want to point out also that the cam ring and other cables on the cam region are, perhaps they will be open also to test some kind of wet tests. And they are taking care of that also. And I do believe that they can complement both wet and dry testing, and in the benefit of the quality of the information that will be get from the seafloor. Okay. Yasser, do you want to complement?
No, I think that's perfect. Let's do it.
Maybe, Jose, maybe you could wrap it up because you are 20 minutes, was most interesting, I mean, presentation and discussion, but we are about 20 minutes late already in our,
okay.
okay, so please wrap up and yeah.
Just one question, José Luís. The email addresses from Leia people are available. Perhaps who knows to address them directly, they should do it and contact them and dialoguing with them in the benefit of everybody. That should be nice. Okay.
Yes, I'll share the mail, okay.
Then for me, José Luís, that's I would like to thank Yasser Omar and the Leia team to this presentation. I thank you also everybody that have been patient and was listening us and watching us until the end. And I will give you the floor to José Luís Moutinho from the Air Center. And I thank you very much for organizing this. Thank you.
Thank you, everybody, the panelists, Jose, Yasser, also, not Bernardo, but I couldn't get your name, sorry. And everybody who participated here, Belal, Wendy. And just to tell you that next week, at the same time always, I mean, 1 p.m. UTC, we will have Sheila Hemans from European Marine Board, and the moderator will be Wendy Watson-Wright from 7 Mile Bay. Okay, so I hope to see you next week. Thank you again for this fantastic afternoon. Have a nice.
Thank you very much,
Stay
José
safe.
Luís, and thanks to the Air Center for the invitation. Thanks, José, for the introduction. Thanks, of course, to the Leia team, our team, and nice collaboration. And thanks everybody for the participation. And we're very happy to continue these Atlantic interactions by email or other channels.
Okay, bye everybody.
Thank you. Bye-bye. Thank you very much. Bye.